find the density of this irregular object, we need to find its mass and its volume. To find its mass is very straightforward. We can use a top-pan balance. But to find its volume we're going to have to use a different method, because we can't use a ruler to measure the dimensions of this object because it's got an irregular shape. So we need a different way of doing this. This was solved by Archimedes back in the ancient times using what we call a eureka can. We can find the mass of the object using a top-pan balance. So first of all, we need to make sure it's on a flat, even surface, and then switch it on and then check it's zeroed. So when we look, it reads 0.0. I can now place the object on there and then read off the mass of the object, 85.0 grams. I'm going to find the volume of the object using this can called a eureka can. And what you have is a measuring cylinder with a spout on the side. And I'm going to fill it right up to the top with water so that the water comes out of the spout. I'm going to allow the water to settle so that I know that the water is right at the bottom of the spout. Now, history tells us that Archimedes did this using his bath, and he jumped in his bath and the bath overflowed, and he could work out the volume of the king's crown by how much water was displaced when he placed the crown inside the bath. So I've emptied the measuring cylinder and now I'm ready to place the object inside the eureka can. I'm going to place it in very carefully because what I don't want to do is splash any of the water out of the sides of the can. So that's an accuracy point for us. So when I place the object inside, water overflows and fills the measuring cylinder. And we allow all the water to come out of the eureka can, and the volume of the displaced water here on the measuring cylinder is the volume of the object. I need to check the object is completely submerged in the water, which it is. And then once it's finished dripping, I can measure the volume. When I record the volume of the water, I need to make sure that I get down to eye level to look at the measuring cylinder so that I can be as confident as possible that I'm reading it accurately, and take into account any meniscus, or where the water curves slightly at the edges. So when I look at here, I can see this is 26 centimeters cubed. So as before, now I can find the density of the object by density is equal to mass over volume, and the mass is 85.0 and the volume was 26. And that gives me a density of 3.3 grams per centimetre cubed.